ISO 8601. When programmers write programs, at some point or another, they need to express a time and a date. For example, when you receive an email to your inbox, then if you look at that email, it has, of course, the subject, the body, and also has the time that it was sent, time that it was received. And if you view the source of that email, you will see multiple times represented there. So now the question is, how do we represent time, both in email, over the internet, over programs, over databases, and in general in programming languages? What is the best way to represent time? So believe it or not, this was a real issue. How do programmers and how do machines represent time, not at the byte level, but at the representation level in variables, and how you store them to databases and how you communicate when you pass an email, which is a piece of information. How do you represent the time there? So it was a real problem, and people did not use up to the ISO 8601 and the adoption of it a standardized time and date reference. So let's see first what were the problems. The problems were, you might have heard also of the millennial problem, is that when I specify to you a date, when you specify a date to your friend, so you say, I'll meet you next week at 4 o'clock. Okay, so 4 o'clock, is that AM or PM? When you tell the computer 4 o'clock, it needs to know whether it's AM or PM. Also, the computer needs to know he's not your friend, he's not living in the same country, okay? He did not have any plans to meet you next week. So the computer needs to know also the time zone that you are speaking with. Is it time zone GMT -7 or is it time zone UTC +2? If you don't specify all this, the computer might assume, okay, the programs that run on it might assume the time zone. So you need to be you want to be explicit about it, because last time we programmers were not explicit about something. We said the year 98 in the program to the computer, then the year 2000 came and surprised us, and then we needed to convert all the applications to adopt 4-digit dates or milliseconds based since 1970. Okay, so we have a few problems that we had and we needed to resolve. And among these problems were, if I have a date like 10/9/98, is the 10 the month or is the 10 the date? Okay, what comes first, the date or the month, right? So we need to first solve this ambiguity, then we need to solve the ambiguity of the year, okay? And then we need to tell what is the time zone that we are working with, and we need to say whether when we say 6, is it AM or PM, and we need all to agree on the time zone, okay? So this is what the ISO 8601 did, and before that, you have to know that there were attempts to resolve the time representation in email. And there was RFC 822 and then RFC 2068, and there were variations of them. And this was about represented date, which was used on the internet, especially in particularly on email messages. And the way it looked was like something like for Friday, 8 of May, 1998, space 1557. So you already see that we have spaces, we have for Friday. Okay, this is a mess. This is not the way to represent time and date to the computer. Okay, we want something concise. And it would be great also if both humans and computers could look at this datetime and both could understand it. Because if I give the computers like in Java, system.current time milliseconds, he would perfectly understand this. Okay, but a human that will look at this timestamp and we see 2178, okay, this does not mean anything. We need to take this number, convert it into some clear date, and then we understand this. But if we represent to the computer, if we communicate with our programming language, at least with the interface of our programming language, with the interface of the database, with the APIs that we use, if we use the RC8601, then we represent the date in a human readable way. And what the computer does behind the scenes, we don't really care. Let it convert it to milliseconds, convert to microseconds, whatever it wants to do with this, at least as of this session. It's very interesting, but not for this session. So 8601 RFC basically thought about all these things and decided that the DateTime representation would be first, that everything would be represented with UTC time zone. Second, that there would be no ambiguity as for where is the date and where is the time. So we resolve the ambiguity with the time zone. It's always UTC. We also resolve the ambiguity with the date and the time. It would always be in the same place. And it also went a step further and wanted it to be human readable. So the date is not going to be the current time milliseconds. Okay, it's going to be real date that human can look at and deduce automatically what it is intuitively. Okay, so let's now look at the formats of the how do you represent time with ISO 8601. And when you use your programming language, then it's very simple. You just say this is the format and this is my date. So if we represent a date like 21 of June, then the way you would write it is 2020-06-01. So as you can see, we are already, as we said, we're going to be consistent. We're always going to start with the year, then the month, and then the date. And our separator is dash. And you would see that our separator is never going to be space. Why not space? Because space is complex to mess around, especially like in Bash and etc. And just less makes sense when programming. And then if you want to add the time, then you add the letter capital T and then the time. So the time could be 13, 40, and then could be 00 for the seconds. And so you have the date, year, month, day with a dash separator, T, capital T for beginning time. And then you start the time. Okay, you write the time, but this time the separator is not dash, it's colon. Very simple. And you add it with Z. Okay, when you add it with Z, this simply means this is UTC. This is the end. So as you see first, when we didn't have the time and when we do have the time, the prefix is the same. The prefix is always the year, month, day, and then the time. Okay, it's not that if you want to represent that then you can exchange them or do anything. No, the order is always the same. What does it mean? It means that if you want to compare two date times, then you can just do that. And you can do this lexicographically. So if you compare two strings which are having ISO 8601, you can basically know which time date comes before the other in date manner. And this would be the same as comparing the strings. So we got another benefit from this representation and consistency. And I think this afflicts to many aspects of software developments. That when you are consistent, then you get additional benefits. So we said that the time zone is simply the UTC, and you can define the time in many ways. So in the ISO 8601, you can define a date-only format, which would simply be a year, month, day, that's it, with the dash. You can also define only time-only format, time of the day-only format, which would be our minutes separated by colons, or our minutes seconds. And you could also define the time zone. Just add the time zone as a postfix to your time, okay? With an explicit time zone. But if you don't define the time zone as an explicit in an explicit way, then it assumes that it's UTC. It also allows you to define a period of time. A period of time is like year, month, day, time, and then slash. With the slash, you define the end time. So it's like the start time date slash and time date. So it's not only handling date and times, but also periods, which is great. So we have like almost everything that we want. We have a human readable representation of time and date. We have a computer readable representation of time of date, which means it's very consistent. You can lexicographically compare and update it. You know exactly what is the date, what is the time, because it's always consistent, it's always simple. You know what is the time zone, and you can also define periods for it. The separators, as we said, are for the date, it's the dash, and for the time, it's a colon. Also, if you wondered, what is the Z after the time notation, because it's like 000000Z with a colon separator. So the Z is an abbreviation for Zulu time, which is simply the UTC if you don't specify anything after this. And now let's say that you have at hand an RFC 8601 datetime representation like year, month, day, T, hour, minute, seconds, milliseconds, Z, and then you want to convert it into a date object in Java. How do you do this? First, you define a new simple date format and you give it a format. Year, month, day, you know, YYY minus MM minus DD, etc. Okay, you give it a date format and then you just do a dot parse to this new simple date format and give it a string. Then you have at hand the date. Very simple. So you first define a date format, simple date format, give it a string that represents, you tell it how do you represent the date and time, and you represent the date and time with the YYY, MM, DD, etc. And then you do parse and you get back a date object. To sum up, if you want to represent date time at hand and you want to send it or you want to see it, then it would be great, of course, to use the objects like the date object in Java, etc. But when you want to represent it, when you want to look at it, then there is a specific RFC for this, which makes everything concise and consistent. And this RFC is RFC 8601, which specifies this is the format of how we want to represent date. So if email was redesigned today, then it would sending emails, and in the email there is text which represents the dates. It would be represented with 8601. Okay, it would be represented with a consistent first the year, then the month, then the day, and then the time. So this RFC basically means that we have a way, all of us programmers, to share date time information in consistent way. And if you wonder whether I want a timestamp and whether I want one RFC or another, then no need to ask any questions. There is an RFC for this. It's solving all the issues. It taught about almost everything. It's human readable. It's computer readable. This is the RFC that we should use for representing date and time. Almost no questions asked. So I think this is both an interesting and also an important topic, and it's good that we have come up to finalize the way that we represent date and time in a consistent manner. Let me know what you think, and we'll see you next time.